Slackbots have been around for some time, but I really haven't found them that compelling until now. With large language models, we can actually start chatting with our chatbot like you would a normal person. But there's a big caveat to just using a large language model in what we're going to do in this one, and that's this question right here. How do you define URLs? If I hit enter, if I were to ask like OpenAI's GPT or Llama 3, I might get a response back that I'm expecting, but in this case, I get a very specific one related to Django. Now, the reason for this is what we did was we took a PDF document of the Django documentation, we turned that into a vector database, and then we actually do a semantic search to that database, and then our large language model infers and guesses what's coming out from all of that data. Now, don't get me wrong, if you want to learn the details of what I just said, you totally could. We are going to be looking at a lot of this stuff from a high level. We will see some of the details there, but the general idea is taking a question like this should be simple, and that's what's going to happen in this series. We're going to be using a tool called LlamaIndex to help us with the AI portion of it all, along with those large language models that I mentioned before. But at the fundamental level, we are going to be building a Django project that has a Celery worker process that then is connected to a Cloudflare tunnel so that our Slack API can actually talk to our local Django project without us going into production. Now, the glue to all of this is thanks to our sponsor of this series, Upstash. We are going to be using Upstash Redis and Upstash Vector for its use cases, like in the case of Celery and in the case of our vector database storage. That's what we're going to be doing in this one. We've got a lot of things to cover. It is a really cool and practical use case. Once you're all said and done with it, you'll be able to take any PDF document or a group of PDF documents and start talking to them just like this. It's really straightforward, and I'm really excited to show you. Let's take a look at a demo, more of what we've got right here. Here's a demo of what we're going to build. First off, open up Slack, and then you can actually type out to your bot. In our case, we named the bot Hungry. And you can say something general like, what version are you using? And of course, we need to invite the bot. Once it's invited, we can go ahead and then ask the bot what version you're using. And what do you know? It gives me the actual version number. And of course, I asked it twice, so it answered twice. What we can also do is say something a little bit more specific about Django, like, can you give me code sample of signals? And then what is it going to do? It's actually going to go ahead and do that exact thing. It will give us a response back with some code samples of signals. Now, the question, of course, is where is this data coming from exactly? We'll talk about that in a second. But the idea here is building out a Slack app that we can use at any given time. And of course, it is a bot, but we can design this however we see fit. Now, all of the code is available for free on GitHub, so check this out as the Django AI Slackbot. And do keep in mind, all of this is running actually locally, even though it has a custom domain name and it is HTTPS. The reason for that has to do with Cloudflare. We use Cloudflare tunnels to actually allow for us to interact with the Slack API, because the Slack API expects a public URL that it can access. Using the Cloudflare tunnels makes it super easy for us to have that connection. Now, of course, we're also using Django, and specifically the Django documentation and this PDF file right here. So what we do is we take that PDF file and we turn it into, well, a index file. So LlamaIndex is what it does. It will actually read that PDF file, turn it into a vector data store, and then we will be able to ask questions to it like we did in this example right here. Now, the actual vector data store is possible thanks to Upstash Vector. We are also going to use Upstash Redis for the Celery worker process. So both of those things are critical components to making sure that this is working, and they are ready to take this into production at any time. We just need to update some environment variables. But that's it. That's all we're going to be doing. It's going to go through step by step. I'm going to discuss things that maybe you don't know yet, maybe you do. And of course, we will use stuff like OpenAI, and we'll also use Llama as well. And then we'll even use Hugging Face related items in there as well. It's a very hands-on approach to building out your own Slack bot that can actually read PDF files. Let's go ahead and take a look at the requirement. Let's talk about some of the requirements to do well in this course. First and foremost, having some experience with Django. That is like making views, some URLs, maybe even models. Having that experience is at least fundamental to do well in this course. which of course means that you know some stuff about Python, classes, functions, variables, lists, those sorts of things. And if you do have a little bit of experience with Celery, that will be helpful, although it's not required. Now, if you need to learn more about Django in general, check out my YouTube channel, cfe.sh/YouTube. And for this series, I recommend doing any of my Try Django series, or you could always do your first Django project course on my website. Then you're going to need to have a Cloudflare account. This will actually help us with local tunneling to actually use our Django project on the open internet from our local computer. It's really great. And then, of course, thanks to Upstash for helping us with this series, but you're going to want to create an Upstash account so we can use Redis and the vector database. Then, of course, we're going to be using OpenAI for a number of things related to how our bot's going to end up working. And then you'll probably want to have a Slack account and some things like that, which I sort of assume that you will have, given that this is a Slackbot series. So if you do have any questions at this point, let me know. Otherwise, let's jump right into it. Whenever you're developing in a local environment on your local machine and you need an actual URL, a public URL, what you end up using are things called tunnels. Now, one of the ones that I've used for years is called ngrok. So you can use ngrok HTTP 8081. That, of course, is going to be the port on my local machine. You hit enter. That will give us a public URL with TLS already in there, or HTTPS, that will actually take this URL and forward all requests to our local machine at this port. Now, my local machine is not running anything at this port right now, so if I were to go to this URL, I get this connection error, which is totally okay. But the problem is not that. The problem is this. As soon as I want to restart ngrok, I get literally another URL. So if I refresh in here, this one just no longer works whatsoever, which is not ideal. So instead of that, we're going to be using Cloudflare. Cloudflare does something very similar to this, but it's on our own domain name and it runs in the background. So basically we could just have this URL always running, or we could turn it off whenever we want to. Either way is totally okay. The end result is going to still forward to our local machine because that's what tunneling is all about. Now, you could probably use this in production just fine. That's not something we're going to be doing. We just want to do it in local development, mostly because Slack's API itself, as soon as we want to send out webhooks, we want to be able to develop on top of these webhooks, and that's going to have to happen with an actual public URL and one with HTTPS. Now, the other thing we could test with this is OAuth as well, which is not something we're going to do at this point, but that is definitely something else you might want to consider when it comes to Cloudflare. So you're going to need to buy your own domain name at this point. If you have an old one that's just sitting around, you can use that one as well. But the idea is, if you want to use Cloudflare, you have to use your own domain. If you don't want to use Cloudflare, go ahead and use ngrok. Just be aware that you'll have to update this URL in places that is necessary. It's not really that big of a deal to jump into the API and change the URL, but it gets a little tedious and annoying if you're doing a lot of changes over weeks and you need to change the ngrok URL constantly. So let's go ahead and now set up our tunneling process within Cloudflare. Now we're going to set up a Cloudflare tunnel. The way we're going to do this is by adding in a domain name to our Cloudflare account and then going into Zero Trust, then into Networks, then into Tunnels, and adding a tunnel. That's it. That's really all you need to do. This does mean that we need to install Cloudflare locally, which we'll talk about when we get there. But the first thing I'm going to start out with is an actual domain name. So back into my Cloudflare account, I'll go in here and I'll hit Add Site. Now, of course, if you actually purchase a domain name from Cloudflare, that will already be in your website's list in there. But in our case, I'm going to just pretend like you don't already have one on Cloudflare, and then we'll go ahead and do something like cfetest.com, and then I'll go ahead and hit continue. And then notice that there's plans that you'll need to pay for, or you can scroll down and see that there is a free plan that you can use for all of the DNS related things. We'll go ahead and confirm that plan, and I'll just let this run for a moment. Now, in a new tab, I will actually re-navigate into this website, and I'll discuss as to why I already have one in here that I will use. Now, the reason being is if I go into cfetest.com, the DNS, the name servers, is what I need to update on my actual domain name registrar. So wherever you purchased your domain name, you need to change your name servers to these two right here, whatever your values are. They might be the same, they might be different. But the idea being that once you change your name servers here, then that domain name will be managed by Cloudflare. This is going to be true for other values, as we'll see in just a moment. This process can take 24 hours. It could take longer than that. So if you're really in a hurry and your domain name's not ready just yet, feel free to use ngrok going forward just to get some of the basics down, because changing out that domain name is not that hard to do in the future for any given service that you're trying to use a public domain name for on your local development. But the idea for me is I wanted to have my domain name already ready for this series, which is why I have hungrypie.com. cfetest.com is not a domain name I actually have, so you'd probably remove it from your account, which you totally could. No big deal there. But the idea is once you put your domain name, all of your DNS records, whether it's the A records, whether it's C names, anything like that will be handled through Cloudflare. So that means all of your requests will be driven through Cloudflare and potentially proxied, which is really nice. It can actually do a lot of features that are just outside the scope of this series. But overall, it's a really powerful service and one that you might want to use more of after you use these tunnels, which I think is why these tunnels are free, because they're so valuable to us developers. But the idea here is let's go back into our websites. I'm going to be using hungrypie.com. The little check mark shows that I've got the ability to have traffic coming in and all that. And then I've got DNS records in here, some basic DNS records related to my service and domain, just to make sure that it can't be spoofed and stuff like that. But the idea being that once you have your domain ready, it's time to actually start adding in your tunnel. So going back into the root of your account, we're going to go into Zero Trust here. We're going to go into Networks and then into Tunnels. And we're going to go ahead and add a new tunnel. Right, so what I'm going to do here is just Cloudflare tunnel. You can use other ones, but I'm going to just be using this one, this single connector. There's probably other ones that will come out in the future as well, but I'm going to use Cloudflare's one. So we'll go ahead and hit next, and we want to name this something. In my case, I'm going to call it my Hungry Pie tunnel. Now, I want to keep it very clear. You can reuse this tunnel on other projects. What's going to happen is it's going to tunnel to a specific port. So when you actually run a port, whether it's 8081 or whatever port you decide, whenever you run a service on that port, this tunnel will be in action. And we'll see that in the future as well. But the idea being that we want to call it something. In my case, I'm just going to leave it in as Hungry Pie. I don't need to name it tunnel because it is a tunnel. So I'm going to go ahead and save that, and then I'll see something like this. Now, you're going to need to download and install it for your local machine. I found these instructions really easy. And so in my case, I have Homebrew installed on my Mac, so I can run Homebrew and just run these different connectors and all that. Or if I already have Cloudflare installed, I can just run and install it just like this. So I can call that command and run it just like that. And then, of course, put in my admin password. And there we go. So now my Cloudflare service is connected, which will show me that right here. Right? Okay, great. So the thing is, what I want to show you, though, is now that it is connected, every once in a while, you might want it to not be connected. So if I clear this out and just run sudo Cloudflare service uninstall and hit enter, that uninstalls that service. And of course, you can go back into Cloudflare and eventually this will say it's disconnected in there. But after you actually do connect it, then you'll come through this process. Now, since I just installed it and uninstalled it, I'm actually going to delete this tunnel, restart it, and get back to this screen because I don't want that tunnel key being exposed. But the idea now is, what do we want to do to actually access our local environment? What domain name do we want? So in our case, we could call it something like dev dot and then an actual registered domain name. Now, notice that CFE test is on here. This is a domain name that has not been verified yet, but you can still set it up, which is cool, but also a little misleading potentially. And so in my case, I'll just call it dev.hungrypie.com. And then I want to actually forward it locally to HTTP. And this is going to be localhost. And I'm going to use 8177. I like doing that port value. But the idea then is as soon as I save this tunnel and as soon as it's connected, in my case, as it's connected, I can then go to dev.hungrypie.com and hit enter, and I get this bad gateway. So this is actually a good sign because it's actually showing me that it is sort of working, right? So then if I go into dev, let's go ahead and just jump into, I'll make a directory called test. We'll cd into test, and I'll go ahead and create an index file. So I'll do nano index.html, and I'll just go ahead and just do a really bad one just with an h1 tag of hello world, close off that, and save it. Python 3-m HTTP server, and then 8177 as our port value. Then I'll refresh in here, and there's my hello world. So that's showing me that the tunnel is working correctly. So of course, if you have any issues getting to this point, realize that this command right here is built into Python 3. I sort of assume that you already have that installed because we're going to be doing Django very soon. But this is the part that we need to for sure be at before we can really move to the next part of using Slack with Django and all of that. But overall, once you have your tunnels installed, you can delete them just like this. You click delete, and then notice it gives you that same command that I told you about before, which was uninstalling that tunnel. It's a good idea to always uninstall that tunnel because, well, you basically don't want it to run any sort of tunneling service whatsoever if you intend to delete that tunnel. So that's the point there. Okay, great. So now that we've got our tunnel up and running, it's time to actually start the process of building out our integration with Django and Slack. Now we're going to go ahead and configure our Django project to say hello world to the actual world, because with that Cloudflare tunnel, we'll be able to actually access it on the internet anywhere in the world without pushing it into a production server. It's just going to be our local development environment. Now, the way this is going to be run is by using Python 3. And of course, in my case, I'm using Python 3.12. You could also have Python 3.11 if you need, if that's the one you're using. You might even get away with Python 3.10, but anything below that, you're probably going to run into issues, and it probably won't work unless you use a different version of Django, of course, which is probably fine, as I'll touch on in a moment. If you're on Windows, you're going to be probably using the absolute path to Python, something like this, where it's Python, .exe. That's often how you actually call Python on Windows machines. Not always. Sometimes it's just purely Python. Now, if all of this is new to you, then you might want to go to try Django itself, and that I will reference again in a moment. So what we want to do is we want to create a virtual environment for our project, then install Django, then run Django. That's all we're going to be doing right now. So what we want to do then is we want to make a directory for this project. Now, the way I do it is by using make dir-p ~dev/Django-Slack. Now, this should work on Windows PowerShell as well, the same exact command. And all that does is it puts me in the ability to have the dev folder, which I put all of my projects in. And then I can see that it's the absolute path, but it's sort of relative to my actual user. Hopefully that makes sense, and hopefully you're already aware of that. But now that we're in the root of where I'm going to store all of my code, I want to go ahead and do Python 3 and then -m venv. This module right here is built into Python. It manages virtual environments for us. Hopefully you're aware that virtual environments help separate our Python projects from each other and also from the main system itself. And so I'm going to use venv and then create a folder called venv that will actually host the virtual environment itself, just like that. Now in Mac and Linux, we'll go ahead and activate it with source venv bin/activate. If you're on Windows, it's something more like venv scripts/activate, and that's it. Right? If all of this is new to you, once again, go back to try Django. But the idea now that we have the virtual environment activated, I'm going to go ahead and run pip install pip and Django and then --upgrade. You could always do Python -m pip install and do that as well, but I'll just leave it in as this. Now that we've got this, I want to point out that we are using Django 5, but everything we're doing in this project with a few configuration differences can be done with older versions of Django, so it makes sense that newer versions of Django will probably do this as well. Of course, there might be caveats to that at some point, but Django is pretty stable and pretty modern, and a lot of things don't necessarily change that often. With that in mind, let's actually see something that will change or something we need to configure. So the first thing we need to do is we need to make our src directory where we're going to host our Django code. And of course, that's in this location now. And I'll go ahead and do Django-admin, start project, and then I'll call this project CFE home, period. This is the name of every project I use for Django in Coding for Entrepreneurs. Every once in a while, you'll also start to see app. I'm starting to like to use app now, but I do like CFE home as well. So I'm going to leave it in as that. This, of course, is what you'll get. Now I can run python manage.py, run server, and I'll go ahead and use that port that we set up in Cloudflare, 8177. If I hit enter, this is what we'll see. So we're really close to being able to have this on the public internet. Let's go ahead and take a look at dev.hungrypie.com, And what we'll see, of course, is invalid HTTP host header. We need to add it to allowed hosts. This is a really easy fix. Let's go ahead and open up our project inside of a text editor. So to do this, I'll go ahead and just do code period. This, of course, will open up VS Code. I'll go into my settings here. Inside of allowed hosts, I'll go ahead and do the host I just had, which I'll close this out for a moment, which is dot, and that's going to be hungrypi.com, right? So this is allowing that host. Going back into the terminal, I'll go ahead and run this server again. Yes, I realize I can do all of this in VS Code, but we'll just leave it separate just for now. Then I'll go ahead and go back into hungrypi.dev or dev.hungrypi, and we see our Hello World Django project. But we're not quite done yet to fully have this set up, because if we go into admin, granted, I haven't set up anything within Django yet, but if I try to go ahead and log in here, I'll get this forbidden CSRF verification error. Now, this is definitely something that's newer to newer versions of Django. So there is one more setting we need to set up, and that is CSRF trusted origins. This is not always that obvious until you run in to this CSRF verification problem and you're like, what is going on here? Of course, if you do some digging, eventually what you'll find is there's another setting called CSRF trusted origins. And so I tend to do this right away because we need a trusted origin. And we need to start with the actual protocol, which in this case is HTTPS. And then we're going to go ahead and put dev dot, and then of course hungrypi.com or whatever your URL is. Now the one caveat is if you are using ngrok and not Cloudflare, what you would do then is just go to ngrok and then HTTP 8177 and hit enter. Then you'll go ahead and grab whatever this domain name is and you'll put it here, or you could even add it if you wanted to. And then in our allowed hosts, you would do something like .ngrokfree.app, because that of course is the domain. Using that dot means that subdomains will work as well. Now, I'm not going to be using ngrok, but I just wanted to show you that for those of you who are, and also just understand that you can use both of these at the same time. You can use ngrok and Cloudflare. You would just have to use different ports for each one, most likely. That'd probably be my recommendation. Okay, so with this in mind, let's go ahead and clear out ngrok, and then I'll go ahead and run the Django server again at port 8187 or 8177, and then we'll go ahead and jump into our admin again, and I just want to try to log in and just get a user does not exist type of thing, or some authentication error, or a table error like this, because I actually haven't run any migrations into Django yet, but at least it's not a CSRF error, something related to that CSRF trusted origins that we just started. But now we have Hello World from Django for real. So it's actually pretty straightforward. Now, if I went way too fast for you, or this is outside the scope of anything you're familiar with Django, this is definitely too advanced for you. And you should check out some of the Try Django series because it'll go a little bit slower. Now, I won't cover that much of Django in this series. It will only pertain to actually working with Slack itself and how we need to store the data and how we can maybe integrate with a few other services and also something like Celery. So the Django part itself is going to be minimal. It's not going to be a full feature Django app, but it will have a number of features that kind of need you to know some things about Django going forward. Now we're going to start the process of creating your Slackbot. Now to do this, we want to go to slack.com, create an account on Slack, and create a fresh new workspace. So if you already had an account, just create a new workspace that you can work in so that it looks like this, and there's really nobody else in there, so you can really communicate with the bot you're trying to build and have nobody else causing issues for that. Once you're here, you'll go to api.slack.com, you'll jump into your apps, and then you'll go ahead and create a new app. We're going to be doing it from scratch. Next up, I'm going to call this my Hungry Pi app or something like that. Hungry Pi bot, maybe. And then I'll go ahead and add it into my Hungry Pi workspace. I realize there's a lot of redundancy here, but that's okay. We'll go ahead and just create that bot, and this is where we're going to be working on from here on out. So in the next part, we actually need to set it up to where we can have event subscriptions coming through for a bot. So if I turn this on, right away we see request URL here. Now we will use a URL that is going through Cloudflare and also of course going to our local Django project. But before I even get there, I need to test a bunch of things out, and I actually want to create a designated endpoint. But once we do, we will be able to subscribe to bot events and also other events if we wanted to, but we'll be doing the bot events themselves so that we'll be able to communicate with the bot going forward. Now, another thing to note is you can absolutely use OAuth in here as well. You can actually have Slack users log into your Django project through Slack. This is completely different than what we're building. This is just an authentication method, and it would be using something like Django OAuth to do that, which definitely can happen. And now that we have our Django project configured with Cloudflare and our own domain, it's so much easier to make it happen. Yet another reason to do this. But of course, we're going to be focusing in on the bot stuff, the webhooks that are going to be handled from our application and responding to our bot requests as they come in. So now let's go ahead and actually create an endpoint, a URL inside of our Django project to handle any sort of event subscription. The way our Slackbot is going to communicate to our Django project is through a concept called webhooks. This really just means that Slack itself is going to send data to an API endpoint that we design, that we configure. And this is going to mean that we have to set up a few things related to it in order for this to work. Now, the way we're going to test this is directly in our bot itself under event subscriptions. And if we turn this on, right away it's asking for a request URL. So we actually need to design that. And we'll see that it says HTTP post requests have to come here. And they come with a challenge parameter. And we must respond with that same value. It's fairly straightforward as to what that ends up meaning or what that ends up doing. So that's what we need to build now. Now, before we go too deep down this, I want to remind you back to when we created this admin and we went to log in and we saw this CSRF verification error. Now, this is a security measure to ensure that invalid data or malformed data is not coming into your Django project at all. So this is something that's critical. We want to make sure that we have CSRF. So what we're about to do is going to violate this part right here. We're going to disable CSRF so that we can actually get these bots in. So we need to discuss how all of that's going to work. Of course, I want to keep it enabled everywhere else, so I'm going to put this trusted origins back in. But the idea being that we absolutely want to have CSRF going, and when we have our errors on the Django admin side, this is an acceptable error at this point. But of course, we could always change that and modify it by going into our app and then running Python manage.py and migrate. Now, do keep in mind that I actually added this into VS Code and added a few things off the video, but overall it's still the same. But the idea being, once you actually have it set up correctly, this is the proper error that you'd want to see when it comes to validating form data from your Django project. Now, this error is not going to be very obvious when it comes to webhooks. We want to make it as close to obvious as possible, so that's what we're going to be doing now. To make this happen, I'm going to go ahead and create a new Django application. So we'll jump into the root of our Django project where manage.py is and run python manage.py and create app. And we'll just call this bot, or rather start app, not create app, start app and bot. I always forget those. Anyways, so inside of bot, we've got views.py here. This is where we're going to go ahead and work. I'm going to call this my Slack events endpoint. And it's going to take in a request, and then it's going to return something. Now, we're not using the Django template, so I don't need to use render here. Instead, I can just do from django.http. We're going to import HTTP response here. And this is just going to respond with a basic string of, let's go ahead and do hello world, like we've seen before. And I'll give a status code of 200. Great. So now that I have this view here, I want to actually wrap this view in to my URLs. So inside of cfehome.urls.py, we're going to go ahead and do from bot import views as bot views. And then we'll go ahead and copy this path here, and we'll just go ahead and bring in bot views dot, and there's going to be our Slack events endpoint just like that. And I'll just go ahead and do bot and events. There it is. Great. So now we've got an actual URL path that we can use. So inside of my Django project, I'll just take a look at this, and there's my hello world right there. Fantastic. So we now have a URL that we could probably potentially use with Slack. So we paste this URL here, and Slack will immediately try to verify this. Right off the bat, it's going to give us an error because we don't really have a way to verify this. Notice it says your URL didn't respond with the value of the challenge parameter. What did it likely respond with? if you take a moment to think about it or just go to the URL itself, that's what it responded with. It responded with hello world. That's not what we want. So before we can actually start getting there, I need to do something inside of my Django project. And it has to do with that CSRF. So that CSRF is probably an issue as well. So CSRF, we need to have CSRF exempt. We need to make sure that this is an exempt URL here so that it can actually accept post data. The way you do that is by using this decorator here, and you're just going to go ahead and add in this decorator. Once I do that, I can actually print out request.body, so we can see the data that's coming through, and you can even see what the request.method is as well. So with that in mind, I'm going to go back into the Slack API, hit retry, and this time it actually gives us a little bit better of a value. It shows us a little bit what's going on with this, but notice that the body data is this right here. So this is what we should expect. Now, this is where the actual CSRF exempt needs to be understood. We need to understand that we don't want to accept data from anywhere at any time. We do still need to parse out this data to make sure that it matches what we expect. So let me go ahead and open up my terminal here and go back into Python. And what I see here is the data itself, the request body, this part here, and then the post method is coming in there as well. So we do see this challenge value, and I also see the type of URL verification. These things are coming as we might expect. Here's that body data. This is the request they actually sent to us. So with this in mind, I can start to create some parameters here or conditions to make sure that that's happening. So the body data itself, we see that it actually is coming in as a byte string. And for those of you who are familiar with, JSON in general, or JSON or JavaScript object notation, you see that this is actually a JSON string as well. Even if you didn't know that, we are going to go ahead and treat it as such. So go ahead and import JSON here, and I want to parse out this body data here. So what that means is I'll go ahead and say my JSON data is equal to just an empty dictionary. Then we'll go ahead and do try and say JSON data equals to JSON.loads. And then we want to use that request.body. And we also want to decode it. So we'll go ahead and do decode, and this will be UTF-8. So it's going from a byte string to just a regular string. And then we can go ahead and just do accept and pass. So now we've got JSON data in here. So then we can go through this process. If it is actually a dictionary, if it does parse the data correctly, then we can do the next step, which would be the data type, which will be JSON data.get and type. Once again, going back into the actual Slack API, we see that there's a type argument in here, and it has a very specific value, which is URL verification. So basically we can say if data type is not equal to URL verification, then we'll return something different. We'll return HTTP response, and we'll go ahead and say something like not allowed, and we'll just go ahead and do a 400 error here. Otherwise, then we'll go ahead and print out that JSON data. This time I'll get rid of the other data, but we'll print out the JSON data. In fact, we'll go ahead and do print JSON data.get and something like challenge. Okay, so with that in mind, let's go ahead and retry this again. Once again, it's still going to fail, but if we look into our print statement, we should only see one line in here, and that's exactly what we've got. And so we're on the right track as far as verifying this URL. The next part is really just simple. It's a matter of using this challenge. So I'll now go ahead and say that the challenge is equal to this data right here. And once again, we'll say if challenge is none, or something along those lines, then we'll go ahead and return back this value here. Otherwise, we'll just go ahead and return back the challenge. Now, with this in mind, I'll get rid of the print statements, and this will now hopefully verify and validate our URL. There's one more thing that I want to add in here, and that is requiring the post data itself with this decorator. I'll go ahead and add in require post data so that that's the only way you can access this URL. And the reason I do require the post data is because they say right there that they actually send just post requests, that's all. And so with this in mind, I'm going to go ahead and save it. I'll hit retry in here, and we'll see that it is now verified. Great. So if you don't have this working, then definitely go through and make sure that all of this stuff is correct and you spell things correctly. Of course, if the exception is not working correctly, then you can do exception as E and then print out whatever that is, and you can see what's going on with that value. But now that we have this data coming in and we're ingesting it, it's time to actually move to the next process in handling and creating our bot. Now we're going to go ahead and install our Slack bot. Now if I go back into event subscriptions and just do a refresh, I'll notice that it's not enabled. So we need to actually change that. Let's turn it back on, and I'll grab my URL, my original one, and paste this in. This should already be verified, so we shouldn't have to do anything more here. But next we'll have to do subscribe to bot events. So basically we want to add in a bot events in here, the main one being app mention. Right? So once it's mentioned, we definitely want to have that in there. You might also want to have something like channel related things. You could always experiment with these things as you see fit, but I'm going to leave that as is. So go ahead and save that. The next one is we need to add in a few other permissions for this bot. So go ahead and jump into OAuth permissions here. We're going to scroll down a little bit to the scopes. Notice that app mentions read is already in there, which is great. So the actual event is already in there as well as the permission. So I didn't have to do much here, just add in that permission and then back into OAuth. I'll scroll down a bit into my scopes here, and then I'm going to go ahead and add in a few others. So I'm going to do chat write. So I want to be able to send messages as the Hungry Pie bot. I'll go ahead and add in other things related to chat if I needed to. And once again, you can change these as you see fit. Keep in mind that when you do change them after it's already installed, you might have to reinstall it, which is not a big deal at all, but especially in development, but it is something to keep in mind. Next up, we can now also send direct messages as well, or read them and also write them. Great. And maybe you also want to have the history. In some cases you might, for content related to the Hungry Pie bot. And all of this is all related to our bot itself. Great. So now that we have that, let's go back into App Home. And something you might want to do is change the presence in Slack, the actual name and all that. So in our case, we've got the default username. I actually changed this one to Hungry, but you also might want to have the bot being something different, like in my case, Hungry, or you could say something like Docs or something like along those lines. So I'll go ahead and just call this Hungry as a way to just distinguish it very simply. So I'll go ahead and save that. Great. So I can always show my bot as online. Let's go ahead and say yes, because that's how we want to configure it altogether. And of course, we will get a bot token once we install it. Now let's go ahead and install it. Install it into our workspace here. This is what it looks like. So this is very similar to an OAuth flow once you actually bring this being public. But of course, that's not something we're going to be doing in this series. It's all about this just local management inside of our own workspaces. So there we go. We've got this access token now. This access token we will definitely use in the near future, but I'll go ahead and bring it into my project and we'll create a .env file that we need to load in. And I'll just call this my Slack bot OAuth token, something along those lines. And then we'll come back to that in a little bit. So at this point, it should be installed into our workstation. And so if I refresh into our workspace, I should say, there it is right there. And so once we want to do this, we can just go ahead and start sending messages to this app on some sort of channel. So let's go ahead and do @Hungry, say hello there, and send it. Right? So right off the bat, we need to just invite them. No big deal there. And then we'll go ahead and send it once again and say hello there, ! And hit send. So where does this data actually go? Well, of course, if we go back into our project, it should go to the Slack events endpoint. This, of course, is because of, well, how we actually set up our event subscriptions. It should go into that exact same endpoint, just with different data. So what we want to see is the actual data that's coming through. So what I want to do is I'm going to print out the data type and then also print out the JSON data, just so we can see on our console exactly what's happening when we do a message here. So we'll go ahead and run another message and just say hi. And then what we get back, of course, is a event callback. That's going to be our data type. And then all of the data related to it. We'll parse all of this stuff in the next part. But the main thing here is now what I want is a new data type. I need to actually handle the data types just slightly differently. And we'll just go ahead and say allowed data type now. And that's going to be equal to, of course, our URL verification. But now our new one, which was our event callback. This right here. So now we've got 2 that we want. And so basically, if data type not in, that allowed data type, then we'll go ahead and run this. Otherwise, we'll probably get some sort of issue or error back based off of how it's currently set up, which we do need to echo it. But let's go ahead and try this out and see what ends up coming back at this point with it incorrectly set up. So we'll go ahead and say hello there, exclamation mark, hit send. And once again, we are seeing a 400 error happen here. Well, that's of course because the challenge itself. So once again, we do still want to check the URL verification. So we'll go ahead and say if data type is the URL verification, or not is, but rather equal to, then we'll go ahead and check the challenge itself and go through that process, right? So that would be something that we would need to do. At the end of the day, we still want to send back 200 responses. We haven't echoed anything, we haven't sent anything back yet, but we just want to make sure at least the baseline is done. So let's go ahead and do another one with how are you, or something along those lines. And all we really want to see so far is the fact that we have some sort of 200 response. Oops, we don't have a 200 response. Let's tab this one over. And then finally, we'll go ahead and bring in that 200 response in here, just as an equal or an empty string here as success. And the last final thing, here we go with hungry and hi there, enter. And now we're getting that 200 response. But of course, it's not actually sending any messages. So we do need to send messages, and that's something we will do very soon. But before we can send messages, I want to make sure that I'm loading in my environment variables. So we'll set something up for that. When we installed our app, we got this bot user OAuth token. This is what we need to now load in using a package called Python Decouple. The way I'm going to do this is by inside of my SRC here, I'm going to create a new folder called helpers. Inside of there, I'm going to go ahead and create a env.py file. And I'm going to go ahead and load in some environment variable handlers for this. So the first thing is we are going to go ahead and import pathlib. And we'll say this dir equals to pathlib.path of this file. And this is going to be resolving the file path. So this will be the absolute path, and it will work on pretty much every operating system exactly as it needs to. And then we'll go ahead and just do .parent. That will bring me into this folder right here, which means then I'll do my base directory, which will be this directory here, and .parent. This will bring me into the SRC directory. So if you put an environment variable file in there, that will be that base directory then. And then we want our repo directory, which will be equal to the base directory and the parent of that. So that's the entire folder where my actual .env file is. So I want to be able to handle either one of these things and load in those environment variables. So to do that, I'll go ahead and say my base dir env is equal to that base directory /env. And then my repo dir env is equal to the repo dir /env. So basically I want to handle either one. Now this is mostly for my local development. It's not necessarily for production. But once I go into production, the way I'm going to be using Python Decouple is it will load in my environment variables regardless of where a .env file would end up being. So next we'll go ahead and do from func tools, we're going to import LRU cache because we really just want to load this one single function one time. So we'll go ahead and do LRU cache and we'll do git config, and it's going to return something. And then we're going to go ahead and just grab in config equals to git config. Great. So naturally we need to fill this part out. But what I did right here could be used with other packages, which is why I wanted to set this like up front, is it can be used generally speaking with other packages, although how I'm going to use it is going to be different and very specific to Python Decouple. So let's go ahead and install Python Decouple with pip install python-decouple. Really simple. Now that I have a bunch of different requirements, or really just 2 different requirements, I want to go ahead and create a requirements.txt file just to make sure I'm keeping track of these things. So the first one is Django, of course. Now it's Python Decouple, and I'll save it just like that. Great. Next up in .env, we'll go ahead and add in the configuration that we need here. So to do this, we're going to go ahead and do from decouple. We're going to import config, the actual class, and then the repository env, just like that. And so what we want to do is we're going to go ahead and say, now if this base dir env exists, then we'll go ahead and return the config class of that repository env and of that path. Now, it's possible that we might want to make sure that this is a string, not a pathlib instance, so we'll go ahead and do that. If that does not exist, then we'll go ahead and go to the next level, which is the repo directory. And once again, we'll do something like that. If that doesn't exist, then we'll go ahead and use the decouple. So we'll go ahead and do from decouple, and we'll import the standard config function, and then we'll return that back. And so this just allows us to have the different environment variables. Python decouple does not support this natively. This is how we do it. Great. So with this in mind, I'm going to go ahead and grab this and add it into my init file. We'll go ahead and do init.py, and then I'll do from.env. We're going to import that config, and then we'll just go ahead and allow it to be exported basically with all, just like that. So the reason for this is now inside of my bot here, I can go into my views, and all I need to do now is import helpers, and then my environment variable, this Slackbot OAuth token, will be equal to helpers.config, and then it's going to grab that config, and then we can add a default of none, and we'll cast it as an SRT or a string. So this part right here is the same as you would with Python decouple altogether, but now it supports the local different env file paths if you have them. And so that's what we need to implement for the next part to actually echo back the message that's coming through. So if it says hello, it's just going to respond with hello. Now we're going to go ahead and echo a Slack message that comes through whenever our bot is tagged. Now this isn't incredibly practical other than the fact that we can then actually respond with messages when it's being tagged, right? So to do this, we're going to jump into the Slack API's documentation, and then we're going to go ahead and get started, and then navigate down into messaging, and then go ahead and do send or schedule a message. And then we're going to just scroll down a little bit and click on composing your message. And this is what we'll have. So we've got our message payload, or the data we need to send. And then we have a HTTP request with all of the data that's coming through on how we need to design this. Now I'm going to be using Python requests instead of the Python client that they have. This client may or may not be supported in the future. I think I saw it in development mode recently. So using Python requests is just a really simple and easy way for us to manage this process, because the HTTP endpoint is probably not going to go anywhere anytime soon. So let's go ahead and start this process. I'm going to actually copy this whole block here, and we're going to bring it into our views. And then I'm just going to go ahead and create a new function in here, and we'll call this like something like send message. And we'll put in the arguments in just a moment, but I just want to design it first. So really, I'm just going to put in the message data itself, and that's what we'll go ahead and pass in as our data. So that's going to be taking place of this in a moment. So I'll comment that out. Now, of course, the URL then is going to go into this method right here. Then we need to bring in Python requests, which we'll do in a moment. But I still have these headers that I can use in here. So I'm going to go ahead and put in a header, the content type header, and then the authorization header, just like this. And so typically speaking, I see content type as capital, so I'm going to go ahead and do that with my headers here. Then I'm going to do my authorization, and I'll go ahead and say F and something along these lines. Naturally, this token right here is the same as this token. No surprise there, hopefully. But there we go. So that's now the headers. Every once in a while, you might want to put the character set or the char set in here with your content type. And that's something that Slack will warn you about if you don't do that. And then finally, I'm going to also go ahead and put in an accept header in here as well, and basically allow application JSON to come back to us when it's all said and done. So it's basically the same thing as the content type of the data we're going to be sending. So with this in mind, I'm going to go ahead and bring in Python requests. Now to do this, I need to bring in requests into my requirements here. So let's go ahead and add in requests, and we'll go ahead and do our quick pip install of requests here. And then I'll go back into my views, and we will import Python requests. We'll just import requests, and we'll go ahead and set up our requests here. Oops, that's a mistake there. And so the request is going to be, we'll just return request.post. Remember, it's post data because that's what the documentation says. Usually when you are sending data, it is post data, but you always want to follow what their docs say. We're going to go ahead and pass in our URL here. We're going to pass in our JSON data, which is going to be the argument that's coming through. And then we're going to go ahead and pass in our headers here. just like that. Great. So this is how I'm going to send that message. Now, of course, we need to format the data itself on what it actually should end up being. So instead of just data, we'll go ahead and say data equals to, and we want to actually format it based off of what it gave us, which was the channel, right? And then the text itself. There's probably other arguments that we might want to add to this, but basically my message is just going to be the actual message. So we'll just pass in that right there, and we'll pass this in. And then of course we probably need our channel ID. So I'll go ahead and do channel ID and set that equal to none for right now. And then we'll go ahead and bring that in down here. There we go. Okay, so that's our formulated message. We will definitely revisit this again, but it's fairly straightforward, right? So this to me is a lot easier to manage than trying to figure out how they actually run all of their Python related things in here. Granted, there are API errors that you might want to handle for, and there's a number of things that might be a good benefit to using the Python client. But like I've said before, I had some issues with it in general, so this is the method that I want to use. Okay, so with this in mind now, I want to go back into my require post and take a look at the data when I actually do send it back. So let's go ahead and print out that data and just take a look. I also want to print out the keys that are coming through to the raw data. So I'll do keys and the data type, and then finally the data. Okay, so with this in mind, let's go ahead and make sure our server is running. So inside of our project here, Python manage.py run server 8177, like that. There we go, back and running. Okay, so now let's go ahead and actually trigger something, and we'll say hello again, exclamation mark. So when we come in here, it doesn't actually respond anything back yet because we haven't configured it. But what we see is we've got our event callback here, and the keys that are coming through with this event callback. Notice there's one that's called data. So basically what we want to do is I'm going to take this block here and I'm going to copy it to some degree. And now we're going to go ahead and say the event callback. This time though, it's not a challenge. Instead, it's going to be our event data. So we want to grab that event data. So if I scroll up again, I should be able to see that event data that comes through as one of the keys, and we would be able to look through all of that event data, which we will look at it a little bit more, and feel free to explore it on your own as well. But that's the main key that we want to grab. So once we got that, I'm going to go ahead and grab the different elements of this event. So first off is going to be our message text, and this is going to be event.get and simply text. I'm also going to go ahead and say or an empty dictionary here, just basically so that would end up being none. And then I want to grab my channel ID, and this is going to be that event data as well, and it's going to be simply channel. So here's the event data. We've got a user in there as well, so let's go ahead and do user ID is equal to event.get user. So at some point we'll probably have that one. And then of course we've got type app mention. We have a timestamp in here. This will be important in the future. We've got a message ID here, and then we've got the text. Right, so that's this right here. And then if we keep going, we've got team, blocks, we'll worry about that later, and then finally channel. So event.get and channel. So here's the three elements that we'll probably be using in the future, but for now, we've got two of them. Okay, so let's go ahead and now we can send the message based off of that data. So basically, we're going to say r equals to send message, and then we're going to pass in the MSG text, and then the channel ID equaling to that channel ID. And then basically my response is going to be, instead of HTTP response, I'll probably change it at some point, but I'll just go ahead and say success for now, and then we'll use r.status code. So basically, after the message comes through, that's the response we want to send back, whatever that response ends up being. Okay, so with this in mind, we now should have everything necessary to run this echo command. So inside of our app again, we'll go ahead and do hungry and say, hi there, buddy. Hit enter, and there it goes. So it gives me the exact same thing. Of course, I'm tagging myself once again, but that's okay. We'll worry about that in a little bit. And then I can also say, another quick echo and take a look at that. And of course, in a moment, it responds back with that another quick echo. Echoing out this message data is probably okay, but the thing is, we actually don't want to re-tag ourselves in responses. That doesn't really make a whole lot of sense. So what we're going to do then is we're going to take a look at the event data a little bit more, but we're going to use prettyprint to do so. So from, we'll do pprint import pprint, and all prettyprint does is it allows us to see our data broken out in the console a little bit better. Now, there are other ways on how we can actually go through and manage this data, but really I just want to break it down a little bit more so we can see it and change our echo just slightly so it's a little bit better. So the slightliness of it all starts with this block right here all the way down. That's the prettyprint that's coming through. And so we see that there's blocks in here. These blocks have a list of items in there. Within there, we've got elements that also have their own list of items. And what do you know? There is the raw text that we just had in here next to the user ID that's being tagged as well, which is pretty fascinating. So that means that I could actually break this down and grab the block itself. In other words, I can go ahead and say blocks equals to event.get and blocks. We could also say or an empty list. Then I can go ahead and grab the elements from that first block. So elements equaling to blocks, and that's going to be 0, the very first block that's in there. And then we'll go ahead and do .get and elements. And this, of course, is going to be or a empty list because those elements are a list. Right? And I could keep going down that process, or what I could do instead was just go for the message text itself and do something along these lines, where it grabs that block, it grabs the first one, it grabs elements, which also grabs the first one, and then so on and so forth. So that's actually how I'm going to echo things back. And I want to just put it into a try block, basically saying if that data is not there, then just go to whatever the fallback data ends up being. And so with this in mind, I'll send that message, and then I also want to remove any extra spacing in here. So I'll go into the message itself and just do strip in here as well. Great. Now we're going to go ahead and try and echo this thing back with just that raw message. So again, hungry, hello. And now hopefully hungry responds with the exact same thing. Now it's closer to echoing it. But of course, the next part would be actually adding in the user and tagging the user that sent the message right back. Now inside of our send message function here, we're going to go ahead and add in the user ID and set it equal to none. So basically what we'll do is we'll say if the user ID is not none, then we'll go ahead and change our message slightly. So the message itself is still basically the message. We'll do f, or message equals to the f string, and then we'll use at user ID and then the original message, that right here. And so the user ID would then come in just like that, and there is the new message. This is how we can now tag that user. So let's go ahead and take a look with this. And if we scroll down a bit, we still have that same message text coming through. Here's our user ID now, and I can go ahead and pass in the user ID equals to that user ID. Let's go ahead and make sure that our server is still running. And then I'll go ahead and now try this out. Hungry, how are you doing? And then hopefully that will respond back. And sure enough, it does. It tags me as the user, my personal user. The bot does. It works exactly as intended. Now, we can make these messages more robust than this. But for the purposes of this one, at least for now, we're going to go ahead and keep it basically this simple, where it's going to be just like this. Now, what I want to do is I want to take this out of the views and start building out something that's far more reusable in terms of how we send out messages, and we'll create our own basic Slack client right now. Now we're going to go ahead and create a Slack client module similar to like what we did with helpers. So inside of SRC here, I'm going to go ahead and create something called Slacky, and we'll go ahead and do init.py. And then I'll also go ahead and do messages.py and basically just grab this original function here and pretty much everything else that I imported, paste this in here. We'll get rid of the imports that we just simply don't need, which are a few of them, but not that many. And now that we've got this, I'll go ahead and jump into init, and we'll just do from .messages. We'll import the send message and then add it into all. Great. So now back into our views here, I'm going to go ahead and import Slacky now, and good old Slacky will be used to send the message instead of this other one. So back down here, we'll do Slacky.send message, and there we go. So now I'll go ahead and get rid of all of this in here, and including the helpers, And that's how we'll go forward now. Now, of course, at some point, we might want to augment this and change the complexity of the messages that we send. There's a way to have more robust messages than this, than just raw text. There's something called blocks. We can send block messages, which are basically more advanced or rich text that would come through. But that's outside the scope of what we're trying to do here. Instead, we just want to make it fairly straightforward as to how we're sending back any given message for our application. And of course, the actual message text is still coming through with the event data. So perhaps you'd want to base the send message off of some of the event data. But the thing is, what I want to do in just a little bit is I want to be able to send these messages asynchronously to when they're being requested. So now that we have a way to send messages that's reusable, I can then offload this incoming request to something like Celery to then send this message in like 10 minutes from now as if it was building out a report or something like that. Now, of course, the intention of that message is not necessarily understood at this point, right? So how are you doing? That intention is not saying, hey, generate some report for me, or hey, go look something up. But the point of this is really just to see how we can start integrating something like this to where it offloads it and goes somewhere else that we can then work off of in the future. Before we actually go into the process of offloading this into Python Celery or into a background task, I actually want to add in one more feature, and that is allowing for threads, so a threaded response to any given message. Now, the way this works would be basically the MSG TS, the message timestamp. We just grab the event.get and TS. Now, there's also something called a threaded timestamp, so we could do thread TS equals to event.get, and that will be thread TS, or we'll set it equal to the message timestamp if it does not exist. And this is what we want to pass into our send message as another value. So with this in mind, I want to go ahead and take a look at the documentation in here for this. So it's really simple. It's just adding in an additional argument into our message itself for replying to any given messages. And that timestamp could be either one of these things. It could be just simply the message timestamp itself or the thread timestamp. So we'll take a look at both of those and how they work. But the idea is now we just need to update our data for our client to handle that thread timestamp. So to do this, inside of messages.py, we'll go ahead and do thread ts equals to none, and basically say, just like we did with our user ID, if thread ts is not none, then we'll go ahead and augment our data. I'll actually put this after that data dictionary here, and then we'll do our data, and this is going to be our thread ts equals to thread ts. This is going to need to be a string there, and there we go. So now to test this, let's just make sure our server's running. We'll go ahead and now do at hungry hello there, hit enter, and moments later we'll see that there's a reply in here, and there it is. And once again, hungry what's up, and now it should respond directly to that inside of that thread, which may or may not be what you want to have happen. So if you want it threaded like this, this is a good way to do it. Now, the reason I actually think this is a good idea is because then we could do HungryPy, something like generate PDF report, and then in theory, HungryPy would actually handle that, or the bot would actually handle that, and then respond at some point later. So that's really the key here. So now that we've got this ability to make these threads, now we'll actually go into the process of putting it into Celery. But do keep in mind that if you do look into the data itself, you're not necessarily going to always find the thread TS as an argument. As in, you're not necessarily going to find this right here, which is why we default to the message timestamp. Now, this timestamp, what's important is what we don't want to do is respond back to ourselves. Like, we don't want to have a recursive timestamp where we're responding constantly to the same exact one. So you definitely want to do it based off of the message itself. So when we go to change this into a background message, a Celery task, we just want to be aware of the fact that the timestamp itself should go based off of some sort of message out there. And of course, we can always track and save all of these messages that are coming in using Django, but that's not something I'm going to do at this point. I'm just going to leave it as is. And now we're going to start the process of integrating Celery so that we can turn this into a background worker process so that something more like generating the PDF will actually work correctly. One of the bottlenecks of creating a Slack bot will be how quickly you can ingest messages. So if you start getting a lot of events coming through, how fast are you going to be able to respond to those? Now, in many cases, you'll probably be able to handle everything through just a request response cycle right inside of Django as we have so far. But realistically, you should outgrow this really soon. And the nice thing is, outgrowing it really just means adopting Python Celery and putting everything into a background worker process. Just basically offloading those tasks and still sending them back as you have seen and using the client that we created. But Python Celery will run alongside of our Django project so that Django then is just responsible for saying, hey, here's the message. Yo, Celery, go do something with it. And that's exactly what we're going to be doing now. We're going to implement Celery so that it actually handles the messages on our behalf so that we can scale up what those messages can do at any time because our background process will be handling it, not so much Django. So let's go ahead and now implement Celery in our project. So the way we're going to do this, of course, is by jumping into requirements.txt and adding a few requirements in here. So these requirements are fairly straightforward, but the idea being that we want Celery in here. We want the Python Redis client in here. We also want to track the results from Celery. And then also if you need the Celery beat server, you can totally do that. We'll discuss that when it's necessary. So those are the first requirements that we need to bring in here. So let's go ahead and install them with pip install-r requirements.txt. Great. Next up, what we'll do is start configuring our Celery application inside of Django. So this is going to be pretty coupled or tightly coupled with Django and Celery. It doesn't have to happen this way, but coupling it this way allows you to use things that Django has, such as the Django models and any other parts of Django you might want to use inside of Celery. So in this case, I'm just going to be implementing it now with celery.py, and we'll go ahead and create our application. First off, we import OS. Then we're going to go ahead and do from Celery, we're going to import Celery itself. Now, what we want is celery.environ.setDefault, and this is going to be our Django settings module, and it's going to be equal to the exact same thing that we have in the WSGI or even ASGI modules. So the WSGI module already has this in here for us, so we can quite literally copy this and paste it in here. So Celery is going to use the exact same module as our Django application itself, so the exact same settings. Of course, you could change this if you needed to, but that's the default. Next up, we're going to declare our Celery app, which is just going to be the same exact name of app. And so when we run Celery, it's going to be CFE home, something along those lines, just like that. Next up, we're going to go ahead and just add in some of the defaults that Celery has, which is going from the Django configuration and looking for the namespace of Celery. We'll see that in just a moment, and then we'll also do auto-discover tasks, which will mean that it'll look inside of our apps and look for something called tasks.py, which we'll also see. Okay, so this is the default Celery application, and to make sure that it's working correctly, we'll go into our init file inside of our module here, and we'll do from.celery. We're going to import app as Celery app, and then we'll go ahead and just put it into our all call here, and then it will be our Celery and app. And once again, it's just so we can do Celery-A CFE home, basically like that, and then worker or whatever we want to call within our Celery application. Great. So now that we've got that all set up, now it's time to actually bring in the installed apps and some of the settings we might want on settings.py. So the first things are installed apps here. We're going to go ahead and add in the Celery beat. So we'll go ahead and do Django and Celery and beat. And then also results. So I'm going to just go ahead and copy this and do results. Now, previous iterations didn't work for Django 5, but the last few tests I've done work for Django 5. So just be aware of this when Django 5.2 or 6 comes out. At some point, these may or may not work for that version. And if they don't, just downgrade a version. It's probably fine. Okay, so the next thing I'll also go ahead and just put in my bot app in here as well, just to make sure that that is going to be registered inside of my Celery tasks for when I need to do that. Next up are going to be a number of configurations that are related to Celery. So what we need to do with these configurations is prepend them to Celery underscore. This has to do with this namespace right here. So with this Celery underscore, I can do something like the result backend and set it equal to Django-DB. This is the result backend configuration inside of Celery. So there's a lot of different configurations in here, one of them being the broker URL, for example. So the broker URL is the same thing as saying Celery broker URL, just like that, all caps, and that's essentially going to take place of what this is right here. So we'll set that one in just a moment. Now, there are a few other configurations I'm just going to copy and paste. One of them is our beat scheduler. This will allow us to use our Django database to run and schedule various tasks. Now, we're actually going to look at an alternative for this later in the series as well, so you don't necessarily have to have Celery do the scheduling for you. Next up, what we're going to do is we're going to add in a few configuration items as well that are related to, well, how we're going to use Redis, and we'll set that up in just a second. So the main thing is this broker URL. That's what we now need to set. So I'm going to go ahead and import my helpers here. So import helpers, and I'm going to scroll on down and then say this Celery broker URL is equal to helpers.config of that Celery broker URL. And then we're going to go ahead and say default being none, and we'll cast it as a string. Okay, so before I even set that broker URL, let's see what the command is for Celery itself. So I don't necessarily have to have Django running, but I will have it running just to make sure I don't have any configuration issues. Notice that I do not have any migrations picked, so I'll go ahead and migrate everything and make sure that that's running too. And of course, if you have to delete your database and just run those migrations again, it's totally fine because nothing about this really needs our Django database just yet. So now I'll go ahead and navigate into my SRC and I'll run my Celery app. So once again, it's Celery-A CFE home, the name of the module that we created, and then our worker process. And we can just run it just like that. Now, right off the bat, it says it cannot connect to whatever this is. That's the default value for the broker URL. So we want to close this down with Control-C. We'll do that a few times. And then I'm going to go ahead and use this worker process again to run a beat server, but also run the info log so we can see a little bit more data about this. So this will be the command I'll run going forward. If you ever need it, again, just reference it somewhere. I'm going to go ahead and just put it right here just to remind myself what command I need to run for this. Okay, great. So now we need to actually get that Celery broker URL. Now the way we're going to do this is by using Upstash. So on upstash.com, just go ahead and sign up and grab Upstash Redis. Now I'm going to be using the free tier. So everything we should do here will probably fit under that free tier. So you're going to be able to experiment a lot with this. Now, the other nice thing about this is Redis doesn't necessarily work natively on Windows. So just using Upstash already saves a bunch of Windows users a ton of time trying to configure Redis locally. So with this in mind, I'm going to go ahead and create a new database. We'll call this just simply HungryBot, and that's it. Or let's just call it HungryBot, like that. Okay, so the region, select a region that's near you, physically near you. Now, this is not actually that big of a deal because it's going to be fast pretty much anywhere in the world because it's a background worker process. It's just about offloading that and making sure that that works. So even if there's some latency there, that's okay because the latency is going to be much smaller, or the speed's going to be much smaller than having your Django project responding. So the latency doesn't matter nearly as much as it could if you're using it for something different, like caching, for example. So we're going to go ahead and create our Redis database. Look how fast that happened. And all we really need is the connection string right here. Now, you might be tempted to jump at the Python one, and that is still the correct values overall, but it doesn't really do what we need it to do for Celery. So I'm just going to go ahead and copy this command right here, and I'm going to jump into my .env file, and I'm going to just go ahead and paste this in. So here is the string that I want. Now, it's not quite everything that I want. So what I want to do in here is I want to add in one other aspect to this, and that is adding a question mark SSL cert REQS equals to cert none. So basically saying that we don't need to check the cert itself because we will need to connect securely or as securely as possible. But the way we need to do it locally is by doing just this. So you use Redis with an S at the end of it, and then you add this in, and then you'll be ready for your Celery broker URL and just do something along those lines like that. Now we should be able to connect to our Celery broker. So I'll go ahead and hit enter and run this. And of course, now it's seeing that everything is connected and it seems to be working just fine. So if I were to Control-C this out and get rid of this argument here and just run this again. Let's make sure that everything's saved in my .env here, and I'll run it again. Now I just simply cannot connect to it. Okay, and so I just want to make sure that I add that in because it's one of the arguments that is required for these settings as it currently stands. Now, the other part about this is maybe at some point there will be an actual argument that goes into settings.py for this instead of what we've got. So we have our backend use SSL and our broker use SSL. We could probably turn those things off and it'd probably work as well. But I'm just going to go based off of this and just basically let it work with SSL and not requiring a certificate. That's pretty much it. So now that we've got this going, everything's all set up, it's time to actually create our background task to then send that message out, which will be fairly straightforward. So at any time now, you can just use Upstash to provision your free Redis instance on Upstash's servers. And then, of course, you can always delete it and just recreate a new one if you need to. There are, of course, limits to this, so you might want to think about how often you're running your Celery commands and stuff like that. If you don't want to go over that free tier, if you want to keep it under there. But overall, I haven't had any issues with the free tier for this entire series in my testing. So just keep that in mind as you go forward. Now we're going to go ahead and do a Slackbot response using a Celery task, a worker task, a background task. To do this, we're going to go into settings.py, make sure that the app that we're going to be using is available. We also want to make sure inside of Celery that we've got auto discover tasks on. So inside of our bot here, we're going to go ahead and create tasks.py, and then we're going to go ahead and do from the Celery, we're going to import shared task. And then I'm going to go ahead and use this decorator of shared task, and we're going to define a function called Slack message task. And it's going to take in whatever arguments that we want. So the arguments that we're going to put in here are actually going to correspond to Slacky or otherwise these messages or these actual responses here. So I'll go ahead and do just that, exactly that. It's basically the exact same, but it's just slightly different. So now I'll go ahead and import Slacky in here as well, and then we'll just do slacky.send message with all of those same arguments. Great, with all those added, we now have basically the exact same thing that we had before. So this time I'm just going to go ahead and return back the r.status code or whatever that ends up being for the task itself, just so that that's going to be the response for the task. With this in mind now, I'm going to go into my views and we're going to go ahead and scroll in here, and we're going to go ahead and do from .tasks, we're going to import that Slack message task. And now what I'll do is scroll down here a little bit, is instead of this one, I'll just go ahead and comment that out. I'll just go ahead and do my Slack message task.delay with all of those same arguments. Now, the important part about these arguments, and all of them need to be JSON serializable. If they are not, then this will not work correctly. Basically, this has to be either a JSON string, which you could totally do. You could totally turn this into a dictionary, make it a JSON string, and then unpack it in here if you wanted to. But in our case, we're just going to go ahead and leave it as is and see if this ends up working. So the first step is to then restart our Celery process. The reason we need to do that is Celery needs to be aware of this message itself. So if I were to restart it, I should now see those tasks coming in here as that message task. So inside my view, it now only calls that Celery task itself, and then it calls delay to make sure that Celery is actually handling it, which we will see here in just a moment. Now, it's certainly possible that Celery is going to fail here. Now, if it does, of course, we'll diagnose it, but it shouldn't, because everything we did is fairly straightforward, and it's really just adopting everything from what we did. We just a slight change to move everything to the background, and we'll just go ahead and do background test 1, 2, 3, hit enter, and over just a short amount of time, we see that that review or that response actually comes through. Fantastic. And if we wanted to, we can update this delay message to be an apply async message. So basically what I can do then is use apply async, pass in keyword arguments, all of the keyword arguments that go into the task itself, which are all of these. And yes, you can pass in message just like that. And then you add in the countdown timer, or how long you want it to wait before it actually sends back that message. So I'll go ahead and say this is just a duplicate, and then I'll put in that original message as well, or we could say delayed or whatever. But the idea being that we can have multiple messages coming through with this async. So we can absolutely still use Slacky or the original one right off the bat and then have it go through everything else. So the very first one could be something like working and then, finishing or done, right? Those are kind of the idea that we could definitely go through. So I don't necessarily have to restart my Celery process for this because the Celery process already knows about this task. I can now use these tasks at will at any given time. So jumping back into our bot here, I'm going to go ahead and say @hungry and say welcome buddy, hit enter. Very quickly I should get a response back, and then over time I should get the actual final response, which will take about 30 seconds before it actually responds with whatever it was finishing that process, right? So finishing or done. And of course, if there's any errors, you will see them in here, right? And so we've got our two tasks coming through. The first task looks like it finished, and it finished very quickly. And then I let it finish the second task. If we go back into Slack, we now see done, right? So we can make that duration be however long we want it to be or whatever's necessary for this running task. So the other part about this is inside of task.py itself, right in here, we could do that same thing, or we can chain together a bunch of different tasks also. So it really gives us a lot of flexibility on how we could then work with this bot itself. But realistically, even just this part right here helps us offload the demand that any given view might have because that data just goes in really, really quickly to the background process. So that part's pretty great. But now that we've got this, we want to start building in more practical use cases for this actual bot other than echoing messages back to us. Now we're going to go ahead and chat with a large language model from OpenAI. This, of course, is generative AI, but it will help us answer questions whenever we want to tag it, essentially turning our Slackbot into an AI Slackbot. Now, doing a generic model like this is probably not that practical in the long run, but it is really nice because we'll start with OpenAI, but you could easily change it to use any other kind of model, including open source ones and using something like Ollama. If you wanted to do that, you would just go into the Ollama blog and then take a look for the OpenAI compatibility. And you can see that the actual code for Ollama can be a drop-in replacement for OpenAI, which is really great. But I'm going to use OpenAI because it's stable, it's really easy to use, and we don't have to configure additional software other than a Python installation. So let's go ahead and do that now. I'm going to install OpenAI into my project. So we'll jump into requirements.txt here, just add in OpenAI, and we'll go ahead and run our pip install. So let's go ahead and do that with pip install-r requirements.txt. Next up, what I want to do is bring in my OpenAI key. So we'll go ahead and do OpenAI API key, and we'll bring that in. So in the documentation for OpenAI, you can see here's something related to the chat completion altogether. So we'll experiment with this a little bit as well. But before I do that, I'm going to go ahead and log into OpenAI. I'll navigate into the API, navigate over to the API keys, and I'll generate a brand new one. And I'm just going to call this my Slackbot key. Keep in mind that OpenAI is not free, and some of the costs might be associated to this. I think the most I paid was $1.50 after a number of tests related to this. It's not really that expensive, but it is something that does cost some money. So you could always use Ollama to do it for free if you wanted to go that direction. Okay, so with this in mind, I'm going to go ahead and create this key here. Now, you could always restrict the key. I'm not going to do that for this tutorial. I think in production, that's when you'll want to do that. But of course, you have to verify you're human. And so I just finished that, and then I'll have this key. Now, I've created this key and deleted it several times for this series in my own, research. So feel free to delete these keys whenever you want to. The worst thing that would happen is you expose this key to the outside world. Just delete it whenever you need to. So now that we've got some of the environment set up, let's go ahead and actually use some of the code they gave us, which is this right here. So I'm going to go ahead and grab this, and we're going to go into our bot here. I'll just go ahead and create a utilities.py method here and paste it in. And I'm just going to call it just this. Now, I could do something very similar to what we did with Slack, where we can actually have our own endpoint, our own Python request module and stuff like that. But the reason I use the OpenAI one is because this is useful in many other places. A lot of other tools work off of this OpenAI one, whereas the Slack one, maybe somebody uses other tools, but probably not. Anyways, so now that we've got this, I want to do a couple things. First off is define get OpenAI client, and we will just change it to being returning back this client like this. So this is for my project. And the key part is those environment variables, and more specifically, the API key, which we'll look at in a moment. And then we'll go ahead and do define chat with OpenAI. And I don't need the two defs, just that. And then we'll go ahead and put in our message, whatever that ends up being. Okay. And so what this is going to do then, of course, is first off, get the OpenAI client. So we'll do client equals to get OpenAI client. And then we'll just go ahead and return back whatever comes back from these chat completions in here. So we'll experiment with this in just a moment. But the idea, of course, being that we pass in our message, and there we go. So one other aspect of these chat completions is this is where you can do some prompting. So if you actually bring in a system role here and say something like, you are an amazing code assistant, or something like that, then you can prompt it out. Obviously, you can add a lot more prompts, and there's a lot of things that we could discuss there. You could probably have entire courses just on prompting these different LLMs. But for now, we're just going to leave it as is. Now, the model itself, perhaps you want to have this as an argument in here as well, so that you can change it wherever you need to, where you have this default value. Okay, great. So, of course, the next part is actually just getting our OpenAI key. Now, just to remind you, of course, it's inside of helpers, and we're just going to do helpers equals to, or rather OpenAI key equals to helpers.config of that OpenAI key with the default being none. Great. So now I'll go ahead and just leave this in here. Now, a big part of the reason I'm doing this as well is for future tests. Whenever we need to get the OpenAI client itself, this just will initialize it for us. The other part about this, having it as that specific OpenAI client, like getting it like this, is the fact that it's really a lot easier to then change it to something like Llama or any sort of other kind of backend, because there are other backends that you can use as drop-in replacements, which is also really cool. Okay, so now that we've got this, let's just go ahead and do our first chat. Let's just see that that part's working. The way I'm going to do this is in the Django managed Python shell. It's probably not necessary to do that, but I do want to make sure that my helpers and all that stuff is working. So being in the root here where manage.py is will be the reason I have this for now. Okay, great. So with this in mind, I'll go ahead and do from bot. We're going to import utils, and then I'll just do utils dot, and then chat with OpenAI. And we'll go ahead and say, hello there, tell me the date. Or something like that. Oops, not utis, but utils. Let's go ahead and make sure we spell everything correctly. And we will get some sort of completion response back here. So the actual response itself comes into the choices. So let's go ahead and say R equals to that same thing. And then we can do R.choices, and we can see that this is a list. So if we look at the first element here, we can see what that element is. And then we can look at the message itself in here, and we can see what that is. And then we can look at the content as well. Now, this is not the correct date, but it is fun that it does respond back with this data. So the cool thing about this too is perhaps I can say something more like raw being false, and then we'll go ahead and say our response. We can do something more like this, and then if raw, then we return back that response. Otherwise, we can return back the choices 0 message content. Great. Now, you might want that in a try block at some point, but for now, I'm just going to leave it as is. And then, of course, you can always change your model too, which feel free to experiment with on. But now that I've got this, I can go into my tasks.py. Now I can just do from dot import utils. And we can just do, instead of this message being to send back or to reply back, we'll go ahead and say my OpenAI message equals to utils.chat with OpenAI of our original message. And that is going to be our response. I'm also going to go ahead and make sure that raw is false here. And we'll go ahead and be able to actually respond with that data. Or in theory, that of course is something we need to test. So first and foremost, I need to make sure that my actual tasks are running in Celery. Sure enough, they are. And so I might need to refresh this because the actual task itself changed. So whenever in doubt with Celery tasks, just refresh Celery and just rerun it again. My Python server, my Django server, I probably don't need to change at all. So now back into our actual Slackbot itself. I'm going to go ahead and talk to this thing, and I'll go ahead and say, what is an SSD? Okay. And so hopefully if everything works correctly, it's going to go ahead and reply back. And it says, great to hear that you're working on something. That's not good. That's not what we want. Let's go back into our utils and see why. Okay. So we've got our message here, and we're getting back some sort of content. So let's go ahead and see what's going on with this. I'll just go ahead and print out the message and the OpenAI message, because that is not at all what we wanted. Let's go ahead and try that again. Maybe it has to do with the model. What is a hardware SSD? Oh, there we go. I realize now. That's funny. Okay, so let's go ahead and see why this ended up happening. But there we go. We've got all of this stuff coming on here. And now what we want to do is come back into why it came out that way. And that has to go with my views here. So this first one just says working. We don't need that anymore. That actually did say, hey, great to hear that you're working on something. That's actually really funny. But now what we want to do is just bring in our message text. And we can still do that apply async. This time I'm going to take the countdown from 30 to 0. I just want to run right away. So once again, we'll try this again, and I'll go ahead and say hungry and say, what is the origin of coffee, or something like that. Okay, and so hopefully this happens a lot faster now. It's not coming for anything else. So let's go ahead and take a look. There you go. Pretty neat. I really like it. So that's it. And so, of course, if we wanted to take the thread part off and just make it a immediate response in the channel itself, I can then, of course, say that and say hungry, what is the origin of tea? And then, of course, it's going to go ahead and respond to that, hopefully quickly. And there we go. So pretty neat. We can now start talking to OpenAI or any sort of LLM that we want to right inside of Slack. But of course, the value from here is going to be using our own data, actually being able to chat with something that's not just generic, but a little bit more robust than what we've got here. Now we're going to go ahead and integrate Jupyter with our Django project. This will give us an interactive notebook so that we can experiment with the next step, which will be LlamaIndex and also reading out a PDF file and all that. But first, we want to get our Jupyter notebook set up. So to do this, we'll jump into the requirements on our local computer, and we'll run our pip install -r requirements.txt, and that will install Jupyter for us. Of course, I'm in the root of the project itself. Next up, we'll go ahead and create an SRC folder here with NBS, as in our notebooks, and I'm going to create a module here called setup.py. This is mostly so that we have a way to make Jupyter and Django work well together. Otherwise, they don't necessarily work well together. So I'm going to go ahead and do this with import OS, import sys, and import pathlib. And then we're going to go ahead and do our NBS dir is equal to pathlib.path. And of course, it's going to be of this file. We'll go ahead and resolve that location and then get the parent. This will, of course, will be this NBS folder here. Then our base dir is going to be based off of that one, which is our NBS dir.parent. Great. Then we're going to go ahead and create a function called init Django. With this, we're going to go ahead and add in our project name. You might already know what our project name is. In our case, it's CFE Home, this project right here. Then after we actually define that, we'll go ahead and do os.chdir to that base directory. So basically to the Django base directory itself. Then we'll go ahead and do syspath and then insert, and we'll go ahead and do 0 and then os.getenv of the pwd. We'll see what that does in a moment. Then we'll go ahead and do os environ and set default. And this is going to be our, well, very similar to manage.py. It's going to be this thing right here. But of course, it's going to be based off of this project name right here. So I'll go ahead and pass that in as the default there. And of course, it goes to .settings. So it's going to look in here for .settings. Now, there's another one that we want to have, and this is specifically for Jupyter itself, and that is Django allow async unsafe. And then we'll go ahead and import Django and then just run django.setup. Great. So this script right here, we need to call every single time we want to run a Jupyter notebook that is integrated with our Django project inside of this notebook folder here. So let's go ahead and try this out with just calling Jupyter Notebook itself. This will open up. In my case, I need to change it to 127.0.0.1, my local host URL like that. Then it does open it up for me. Then I'll go into the SRC, into Notebooks, and I'll just go ahead and say something like this, like hello world. And we'll go ahead and import that setup script. This should give me no problems here. Of course, I hit Shift Enter to run it, and then setup, and then init Django. Before I do that, I will go ahead and do exclamation mark. Let's cut this out real quick. Exclamation mark PWD. That shows me where I'm located. If I run this setup Django now and then do PWD again, it now shows me that it's in the SRC folder itself. So the reason for this is so that I can actually run various Django commands. So in my case, it'll be from django.conf. I can import settings, and then I can see something like settings.base dir or something, whatever setting that you might want inside of your Django project, or from settings.py. That's really the integration portion, but that's all we would need to do, really. If you have questions on this, let me know. Otherwise, now let's go to the process of using LlamaIndex. Now, while our chatbot currently has the ability to come up with some really good answers, and it's probably going to get better as GPTs get better, we want to actually scale it back and narrow the scope of the answers it can provide. Now, the reason for this, of course, is in any given organization, there's going to have a narrow set of documents that pertain only to that organization. And that's really what we want to look at here. We want to have the ability to just narrow the scope of what our bot can actually do. So let's go ahead and start out with just this broad scope, and then we'll narrow it down by using LlamaIndex, a PDF from the Django documentation, and then, of course, OpenAI. So that's what the process will start now. But the first thing I want to do is actually ask my bot something that's pretty general. What is prefetch related, and show an example usage with a query set? If I hit enter on this, this doesn't say anything about Django, but I think that the OpenAI API will actually understand that it's not necessarily needs to say anything about Django. It's just going to intuit that that's going to be the case. So by a glance, this actually looks fairly good. I'm not positive. I haven't tested it. I haven't run through any of these things, but it is pretty interesting on how it actually came up with this code. Now, I actually think this would be even better if we went into our bot itself and we changed the model we're using. Right, we'll probably have even better answers for this general question. But the thing is, it's not answering it based off of our own data. So that's what we want to change. So let's go into the Django documentation here. I'm going to go ahead and click on documentation, scroll down on the right here, and we're going to go ahead and download this PDF. I'll actually right click or control click and hit save link as, and then we want to navigate it into our Django project that we've been working on. And inside of SRC, I'm going to go ahead and create a new folder here called data. And I'm just going to call this just simply django.pdf and hit save. Great. Next up, what I want to do is I actually want to go back into Jupyter, because this is where we're going to test things out. I'm going to go ahead and duplicate this hello world here. And we're going to rename it to something like chat with PDFs. So the way this is going to work is, of course, we still want to set up things for Django. So I'll go ahead and still do that. I only need the Django setup part. That's the first start. But before I even do that, I'm going to go ahead and do pip install, and it's LlamaIndex. Now, we probably will add this into our requirements as well, but I like having some of the requirements that are notebook specific in the notebook. In this case, we've got LlamaIndex. And so we're going to go ahead and run those two things. I've got my LlamaIndex that should install in just a moment, and that's what we're going to be working off of. So generally speaking, we're going to be doing a very simple LlamaIndex feature. There are a lot more robust features than this, but we're just going to be doing the simple directory reader. This gives us the ability to actually run through all kinds of document types, which is actually really fascinating. Even Jupyter notebooks are in here. But again, we just really want to use the PDF. You can experiment with this on your own, but keep in mind that as you experiment more and more with this, it might actually add up the cost that ends up happening to really understand what's going on in any given PDF. Now, in our case, this cost is actually pretty minimal because the Django documentation is not massive. It is pretty big, but it's not as big as it could be. So what we want to do then is we want to actually start that process. Now, the Django documentation, if we look in our code, is inside of this. So I can copy this relative path here, and I'll go ahead and give it my Django PDF, and we'll paste this in here. And I'll just use the relative path to this particular PWD, as in the current path. Of course, we can do that again with that current path. It's in that SRC folder, as we saw before. So now that we've got this, I want to do some imports here. The very first import is going to be related to what we'll do here, the vector store index and the simple directory reader. The simple directory reader can be used by grabbing only the PDF file. So we can actually do our reader equals to that simple directory reader and pass in input files and set it equal to a path to these files. Now, I'm using a relative path here. It'd probably be better to do pathlib and do an absolute path, but I'm just going to stick with the relative path because I think it should work just fine. Next up, we're going to go ahead and read that data. So let's go ahead and make sure that all of this is going. We'll go ahead and do our data equals to reader.loadData. So in terms of LlamaIndex, this is actually preparing all of the documents necessary to actually start using different features of LlamaIndex. Now, I want to make it clear that we will be using OpenAI for this, so there will be costs associated with this. It shouldn't be that much. I think the last few times I did it, it was like 15 cents maybe worth of data, and I would imagine those prices are going to go down over time based off of the actual model that it ends up using, which there's all customizations that you can do for that as well. Feel free to take a look at the documentation itself for LlamaIndex because you can use other models as well. So with this in mind, I now have this reader coming through. I want to actually bring in my helpers. So I'll do helpers. And I'm also going to import OpenAI. Now the reason for that is so I can actually have my OpenAI key in here. And one of the ways to customize it is by actually just coming in and doing something like this. There we go. So that gives me that key. Now that I've got the data read into memory, I can actually start creating a vector index. And we use it from the vector store index. So we can say index equals to the vector store index. And then we'll do dot from documents of this data right here that we loaded in. And of course, we can put more data in here. It doesn't just have to be this one thing. This part will use OpenAI's API, and it will actually create our vector index. It will turn everything into embeddings and all of the vectors that you might need. So I'll go ahead and run that. And after that's all done, I'll go ahead and run basically our query engine, which is essentially taking the index itself. So I'll go ahead and say query engine, and that takes the index dot as query engine. And then we can query that query engine. So I'll go ahead and say R equals to query engine dot query. And then once again, I'll use that same question I asked over here to the regular Hungry Pi bot. So I'll go ahead and bring that question in. You can ask whatever you'd like, but notice that it's asking for that same example. And then I'll go ahead and just do print r.response, and then we'll take a look at what happens with that. Now this might take a moment because it is a number of data items, but something that's important to understand is this index, if I actually were to shut down the Jupyter notebook, this index would not be available anymore. I'd have to rerun it, which means that I'd actually have to save or actually pay for this to be re-vectorized and all that. Okay, so now that we've got this, we've got what is prefetch related. Here is the response. It is quite a bit more narrow of a response than what we've got here, right? Not surprising, really, based off of the fact that it's searching the Django documentation or that PDF that we gave. So we could probably go through here and actually try and find the reference that it's using. Prefetch related, here we go. Here's some of the things related to it. And yeah, so maybe it has the pizza toppings. Notice it's all using pizza. It's really kind of summarizing what's going on right there. There's that pizza toppings, and it's giving us a fairly good example. Now, of course, if I were to try to get more general knowledge, what is char field, right? If I ask something like that, it's probably going to give me something related to the character fields, or what are, let's say, what are the arguments for char field? Once again, it gives me the two arguments. That's great. That's actually a really narrow, quick, easy response, right? So of course, one of the questions you should be asking yourself now is how to actually reuse this index and query engine so that I can actually use it with my chatbot without reinitializing the index every single time. Because that's what would happen. If I had to reload this, the index would then be reloaded once again. So I want to persist that index. And of course, the way I'm going to do that is by using Upstash vector. It's actually very easy to do, but let's actually take a look at how it's done. Now we're going to go ahead and persist our vector index. Now the way we're going to do this is by duplicating our previous notebook here. And let's go ahead and open this up. And I'm going to just rename it to persist chat with PDF. And we'll go ahead and get rid of this copy here. And then we'll run through a number of things related to this. Now one of the things I want to do very first is moving down this reader data just a little bit because I want to load in my environment variables before I do anything else. Next up, I'm going to go ahead and change or comment these things out down here just so that I don't accidentally run them until everything is all up and ready. And of course, the first thing that we need to do is have a place to store our vector index remotely so it's not on our local machine. And naturally, we're going to be using Upstash vector to do this. So go in there, click on vector. Notice that mine might look a little bit different than yours. That's because I've been doing some tests here. But we're going to go ahead and create an index, and we're going to call it Slackbot or whatever you'd like. The region itself, pick one that's closest to you and your computer, of course, and that's going to be true if you go into production as well. Make your production computer as close to this region as possible. Next up, we're going to go ahead and select a plan. There is a free plan. I did a bunch of tests, so I'm on the pay-as-you-go plan now, but of course it's only 40 cents per 100,000 requests, so you probably won't go over like $2 with all of these tests here, unless of course you put it into production right away and you start getting a lot of requests, which would be great. So next up, we're going to go ahead and grab the endpoint and token here, just like what we've got in the actual code that's down here. It's giving us an example that we'll actually use in just a moment. So I'm going to go ahead and copy this and we'll bring it into our .env files. Notice that I already have an example in here. Like I said, I was doing some tests. So go ahead and add vector URL and let's go ahead and grab a token in here and we'll go ahead and paste those things in just like that. Great. So now that we got this, let's go ahead and make sure that our requirements.txt has two requirements that we'll need to go forward. The first one is the LlamaIndex vector stores Upstash, and then the Upstash managed package called Upstash vector. Both things we will use right now. So with this in mind, I have my environment variables all set up, and I can also bring in my requirements here. Like I said before, I like having those requirements in every once in a while inside of my projects just to make sure that they're running. But I'm going to restart this kernel and clear everything out. Part of the reason I restarted it is to make sure that my environment variables are loaded. That's one of the key things here. Okay, so the data stuff is going to be the same, right? So we're still grabbing the same reader, same all that. We can even start loading in this data. But of course, the next part is I actually need my environment variables set up as well. So what I'm going to do then is I'm going to create a new place for all of my environment variables, which of course are going to be my Upstash vector URL and my Upstash vector token. And I just want to verify that that URL is in here. Now, I probably should have verified this before running that data, so that might be something you do. But the idea being that we have the correct URL and it is being rendered here. So next, inside of Upstash, I'm going to go ahead and grab this index stuff right here. Just grab these things because we're going to modify it just a little bit for what we need to do. Now, the reason I have to modify it has to do with the fact that my tests with LlamaIndex were not bug-free. They actually had a few bugs, so we want to just leverage the things that Upstash does already really well by actually using their actual package here. So that's what we'll do is we'll grab our URL, pass it in right here, even though it's the same one probably, and we'll go ahead and grab in our token as well. And that will roughly be what we want for our index. But I want to add in a couple new things for this, or a couple different changes for this. And that's going to be retries equaling to 5, and then retry interval being something like 0.2. This is so that the index, the actual connection process does retry a certain number of times based off of when we're starting to load in our data into this index, which could be vast. We could have a lot of data in here, so we want to make sure that it doesn't time out. With that in mind, I'm going to go ahead and add in one more aspect by using the HTTPX package. this HTTPX package is a dependency of the Upstash vector, so we don't have to install it. What I can do then is I can just modify the client here a little bit. Timeout being HTTPX dot timeout. And we're going to go ahead and do 600 or 500 seconds, whatever you'd like. And I'll go ahead and do it like that. And our connection timeout being a certain number as well. And then we'll go ahead and initialize a client based off of this timeout itself, just like that. Now, keep in mind that this client itself might not be necessary in the future. So feel free to test this out on your own. And so my index.client is going to be equal to this, or rather underscore client is going to be equal to this. Now, I actually want to change the name of this a little bit so it doesn't get confused with what I've been doing with my vector store index. Instead, I'll call this my Upstash index like that. That way we can reuse that actual index name again in the near future. Great. So that alone will then change the standard client, the HTTPX client, to something just slightly different. And then we'll go ahead and do the next part, which is using Upstash vector store. So this means I need a couple new imports in here. And that's going to be our storage context here. And then I also want to bring in my Upstash vector storage as well, which should be imported from here. Now, in my test, this actually changed from the LlamaIndex docs. So I'd imagine it's going to change again in the future. LlamaIndex is like a cutting-edge tool that's out there that's changing all the time. It's not that mature, so do keep that in mind when it comes to using all of this stuff. You might actually have to check in the docs. So at this point, I do have it working though, so we are in pretty good shape. So the next thing is I'm going to go ahead and declare my vector store based off of this Upstash vector store. Notice that I'm passing in the URL token once again. So this Upstash vector store will actually reinitialize a new index value. But of course, I want to use my index value, so I'm going to go ahead and do vector store equals or dot underscore index and set it equal to that. Once again, this is just about fixing some bugs that I found in my own tests that maybe at some point these things will go away. Perhaps you can actually bring in the client and all of these different parameters at some point for that one as well. Now that I've got that, I can then start the process of actually creating my storage context. So storage and context is equal to the storage context class dot from defaults, and that's going to be our vector store equaling to this vector store right here. So all of this is what we will end up reusing in the future. Now that we've got this, let's go ahead and actually create our index and have it go into the remote Upstash vector store by passing in the storage context in here, just like this. So storage context equals to storage context, and we'll also pass in insert batch size, and we're going to change it to about 500. I think the default is 2000, but doing it at 500 means that when we use a remote vector store of some kind, this will actually work more reliably because it's a smaller batch size. When we're working locally, we probably don't need to modify that at all. This is probably going to be true going forward as well. I don't think that's going to change much in the future. So now I'm going to go ahead and run that and just let it actually insert all of those vectors into our new index, right? And so this count will start to grow as that actually starts to work. So next, what I want to do is initialize my query engine. I'm not going to be using this index, but I will be using the same storage context. So I'll go ahead and do my index saved, or let's do index persist. And we'll go ahead and now use something very similar to what we've been doing, which is still the vector store index, but now I can do dot from vector store, and now I can pass in the vector store itself. So vector store equals to vector store. There's probably a way to reuse the storage context as well, although I don't necessarily need to because it's really just adding from the vector store itself. So with this in mind, I can now then do my query engine from that vector store, and then we can run our requests, which of course this means that this is now going to be pretty prepared for our Slackbot, which is something we'll implement in the next part. But I'm just going to go ahead and run all of these things. This will take a little bit of time because it's the first time we're updating this index. So it's going to add in all of that new data that's in there from the actual PDF documentation. So In this case, we've got a bunch of different vectors that are coming through. So let's go ahead and just let that finish. And hopefully by the time it actually finishes this vector store, everything else is really, really fast. And there we go. So we're completely done. Didn't have any errors. Feel free to start removing things to test if the HTTPX is necessary, or even initializing your own Upstash vector index. There's a good chance that those things will be resolved in the near future. But for now, we've got our vector store in here. And so now I can just reuse this whenever I want to. Now, the other thing that's really nice about this is it's really easy to just delete this index and then start a brand new one. You can also transfer it with zero downtime, which is pretty cool too. So if you were to do this for somebody else, you could easily transfer it to their account. So the other part about this now is, now that we have this index persisted, we can actually start using this within our bot and actually start querying things like we see right here. All right, so now we're going to go ahead and convert this Jupyter notebook into a reusable module, basically turning things into functions so that we can actually call it with our chatbot. So let's go ahead and do this now. I'm going to go into File, and we're going to export this notebook as, and we'll do it as an executable script, which of course is going to give us a Python file, which I'll go ahead and open up and bring it into my project. I'll just bring it in right here, and I'm going to rename it to something different. Let's just call it AI.py or something like that. So what we want to do, of course, is we need to get rid of the Django related stuff. We don't necessarily need those things in there. We just need to bring in a lot of the imports that are happening in here altogether. I don't need the reader. This shouldn't be in here at all, but I will need my OpenAI key, that's for sure. I'll need my URL coming through. I don't need to read that data anymore. I will need HTTPX, but let's go ahead and reorganize this a little bit. So that timeout, all that stuff I want to use, as well as the Upstash vector, the index itself, because I definitely want that as well. And everything else I just need to start turning into an actual function. And I'm going to do that by starting from the bottom. Okay, so the first message that I want to have, or the first thing, is just simply query. And this will take in message, and then I'll go ahead and allow for the raw response come through here. And here's going to be the query itself. So we need to get the query engine. So I'm going to go ahead and create a function called get query engine in a moment. Obviously, I don't have it yet. But then what I'll do is we'll say if raw, then I'll return back that raw response. Otherwise, I'll just return back r.response. Right? And so I'll keep doing this until everything is all set up, basically. So the next one is going to be our vector store index itself. Now, in my case, I actually want this to be its own item, right? So I want the vector store index coming and built out on its own. So I'll go ahead and just define this as get query engine. And then this one will grab our vector store. So we'll go ahead and say that the index equals to get vector store index, or something along those lines. And then we use our index here, and then that's what we'll return. Now, naturally, I can change this as I see fit, but I won't need to change it. But if I were to use other kinds of vector stores or other kinds of methods, I could totally easily change it from going forward. So the next thing is, of course, just getting that vector store index itself. So first off is going to be our storage context. So I'll go ahead and define that function now. And we will grab each piece of this, and we'll return back the part right there. Okay, so the storage context doesn't seem to be used at all, so I'll go ahead and get rid of that. Next up, we'll go ahead and grab the vector store itself, which I'll bring up here. Right, simple enough. Upstash index is the next part. So let's go ahead and bring that in. Of course, this could be another function that we break apart, but I won't need to do that at this point. All right, next up, we're going to go ahead and grab the client right here and paste that one in as well. Okay, get rid of some of the Jupyter notebook stuff that's still showing up. Okay, and then the URLs, so all of these API tokens I want to be declared as constants. So we'll go ahead and come in here and do it just like this, as you would see normally anyway. Actually, I'll copy this for a moment and bring it down here, because we reuse those tokens. But then the actual virtual environment variables, we'll go ahead and, or the environment variables, we'll go ahead and do something more like this. to make it more reusable and more Pythonic. Okay, so the OpenAI key I'll actually set up with this get vector store index itself so that it's really applying to that. And then, of course, the token just like that. Great. So that should actually solve the problem of how I have all of this, situated. The other part about this that I do like is that it's basically tied directly into what I did within the Jupyter notebook. So if I needed to change anything, I could test it out in the notebook first and then come on over and copy and paste a few things. So there's one more aspect that I want to do, and that is, of course, getting rid of imports that I don't need. But also, I'm going to go ahead and do from functools, I'm going to import LRU cache, just so that I can cache some of these functions here that I just simply do not need to re-invoke every single time. Mostly the query index itself should just be the same one on this instance of being ran. And of course the message, I need to bring this one in here. Okay, so simple enough. Now I can go ahead and bring this into my tasks. And this time I'll go ahead and import it just like I did with utils here. I don't need the OpenAI message anymore. Now what I'll do is my PDF AI message, and there's going to be AI dot, and of course query. And that's going to take in the default message that's being passed. And then once again, I'll go ahead and say raw is false because we don't need that one. And then we can go ahead and pass in that PDF method back to the response, reply to the message. So now we have the option to do either one, right? So we could do the OpenAI message if we wanted to, or we could do the PDF message. And so we'll talk about that in just a second. But with that in mind, let's go ahead and restart our Celery process here. So I'm going to go ahead and close it down and then restart it. This is just to flush out the task itself to make sure that Celery is aware of the changes that happened, as we have seen before. So now I'll go back into general and I'll go say, hungry, what are you? And then I'll go ahead and say hungry again, what version are you using? So these are very, very generic things that may or may not give the correct answer. So right now it says, what are you? I'm an expert Q&A system. And then what version are you using? Hey, there you go. That's actually closer to the context that was provided, right? So it doesn't say it's Django. It just says it's a Q&A system, which I think is accurate. But then the Django documentation, also accurate. That's the version that we actually passed in our document, in our PDF, which is great. So then I can go ahead and say, give me a model example and see what ends up coming from that. Ideally speaking, it will give us an actual Django model. And let's go ahead and try this again as just another one with hungry. Give us a model example as markdown format and run that and see if we get something closer to what we would want. And here we are. So actual code coming back in a markdown format. Now, if you're not familiar, if you use those 3 backticks, that will actually give you code that you can write inside of Slack. So it's actually rendering code that way based off of the markdown format itself that's being responded. Now, the key thing here, though, is I just said, give me a model example as markdown format. I did not say anything about Django itself. This is showing me that it's most likely using the PDF itself. What's showing me that even more so is the fact that it says Django documentation release, so on and so forth. So what this is not doing is not only using this Django model, it is still using the LLM itself because we can ask for other things. So for instance, if I said hungry, show me a pedantic, model example, this should not be anywhere in the Django documentation, and yet it still might actually give me additional, context related to that. So we can try this again and say, show me as markdown. And there is actually a way to break this. Right now it's saying it doesn't have context for it, but there we go. Right after it said it didn't have context for it, it actually did respond with it. And that's one of the maybe potential downsides of this method of how it's actually going through, and it's still using the LLM to do all sorts of things. But again, it's very similar to the response. It's not a lot different. It basically took the context and interpreted it. So there is a way in the documentation that you can see the actual responses and have them be a little bit different than what we've got here. I'm not going to dig into that right now, but what I will do is I want to actually switch from what we had with our PDF model and just try our OpenAI one. So let's go back into our code here, and our OpenAI message is now what we'll respond with. So go ahead and just use that one instead. So we'll go ahead and comment that out. There we go. So now we'll get that OpenAI message. I'll restart my Celery instance here, and I'll try this all over again using basically the same thing. Give me a model example. And if I go into Hungry and say that same thing, it's going to give me a specific example that's pretty much more broad. It's not going to be specifically to Django. It might be, but in this case, it's not, right? So this doesn't show me much in terms of the actual example itself. But of course, as soon as I bring it back to the PDF, what we will see is most likely the exact same response. So let's go ahead and see this in here. Save it, run it again. And now let's go ahead and call this once again. And now it should once again give me that same exact model because it's doing a search inside of that index, inside of the index that we built out based off of that PDF. So if we were to add more examples of models into the index, it will just search for them. So what's happening here is it's not actually generating new data. It's not actually doing anything new with this data, which is very clear by actually just doing a quick search into that Django PDF. You can quite literally see the model that's the example is in there. It literally says this example model defines a person. Give me a model example. It's actually going based off of that data. Now, it's also in a lot of other places. That single model is in a lot of other places in here, right? So if we actually scroll down a little bit and said something like, give me a musician model, let's go ahead and try that. So Hungry, give me a musician model example as markdown format and run that. Maybe it gives us the exact musician one, maybe not, right? And so in this case, it doesn't. Now, the LLM still helps infer some of this data. It only gave me a little bit of that data, not the whole thing. So yeah, it is pretty useful in the sense that it does read the PDF, but it is not limited to that PDF. It will do other things if you keep asking it because of how the LLM ends up working. So what we could do is we could change a lot of things about this, but this was really meant to be a simple way to get this up and going really, really quickly. That's why it's called a simple directory reader. To make something more advanced, you could do a more advanced indexing or more advanced storing, and then do something like a RAG model that actually you can store all sorts of stuff into a database, and then it will actually make a SQL query for you where it looks in that database. But that's well beyond the scope of what we're doing here. Now you could also fine-tune GPT models and stuff like that, once again, outside the scope of what we're trying to do here. But instead what you could do, this is a very simple and straightforward way to just load up some PDFs and then just chat with those PDFs. And there is references in the actual response. So if you actually were to go through the queried response, this here, you could actually see a lot of the different references that are actually coming through based off of the index response that's coming back as well. So that's another important part of this is, yeah, I'm only returning the text, but that's just to simplify things. There are more things you can dig into within LlamaIndex itself. It's pretty great. Let's better understand what's going on with our query engine in LlamaIndex by customizing our embedding model as well as our LLM. At a high level, what happens is you've got your data. That data gets turned into a vector because of the embedding model. This could be the raw data that gets stored into the vector database. It can also be the data that we're querying with. Whatever it might be, it ends up being an embedding or going through the embedding model that then turns into a vector. Then our LLM will help interpret the results that come out of that process. And that's exactly what's happening. So what I did was I actually duplicated this chat with PDFs notebook to create a new one. And this is what our new one looks like. It's identical to the old one, just commented out a few things here. So in this vector store index process, that's where our text, our raw text, gets turned into vectors with those embedding models. So that's what we can customize. Then when we go to query it, this string also gets turned into a vector because of that embedding model. Then the result, the response that comes back, is interpreted by our actual LLM. So all of this is happening under the hood with LlamaIndex, but of course we can customize it. And the way we're going to do that is by going into LlamaIndex's documentation under component guides and just clicking on LLMs here. And what we got is this customizing LLMs. This is what we're going to be working off of. So if we scroll down a little bit, what we'll see is we can actually use a different OpenAI model if we wanted to. Now keep in mind that you are using the LLM OpenAI model from LlamaIndex. So if we actually go into our PDF here, I'm going to go ahead, or actually our notebook in here, we're going to go ahead and try and import that. Now, this may or may not work for you. Most likely it will fail. So the way that you actually import this is by doing llama-index-LLMs, and then OpenAI. And that's how you can actually install and be able to run this customization right here. So what that will allow you to do then is you can then specify which model you want to work with. So in our case right here, we've got GPT-4. Now the default one is probably GPT 3.5, like Turbo, something like that, because it's really, really inexpensive. It's a lot more inexpensive than GPT-4 is right now. But this is changing rapidly, so it's nice to know how you can actually configure this. And so one of the best ways I think, is by going into our settings here and doing settings.llm and setting that equal to this LLM. Now we can pass this in other places, as we'll see in a little bit, but that's a really quick way to modify which model you end up using. Now you can also push your API keys in here as well, and you can set that equal to your environment variables if you end up going that direction. Now I'm actually not going to be using the OpenAI one. You totally could, and I'm just going to leave it in as comments here, like that. But what I want to use is the Ollama one. So Ollama allows us to run a large language model locally. That's what that LLM is. Llama 3 just came out at the time of this recording. At some point, Llama 4 will be out. So knowing how to customize these things is actually critical. So what we're going to do is we're going to use Llama 3. Now, go ahead and download Ollama. It may or may not work on your system. So if it doesn't work on your Windows machine or your Linux or whatever you end up doing, then you might want to just keep with OpenAI or use some sort of Linux version to make this work. But once you download it, you'll have it on your local machine, and you'll be able to do Ollama and something like Poll and Llama 3. You could always use Llama 2 if you wanted something that's not as big. Llama 3 isn't really that much bigger than Llama 2, but we'll go ahead and run Llama 3 right now. So this allows me to run all sorts of things in here. So like, what is a char field? Something like that. This might be really good in terms of, Django. Maybe not. In this case, doesn't really look like it's going based off of Django. It's just kind of more general, right? So of course we want to change that. So I'll go ahead and say bye for now. And of course the way we change that is by using that inside of our PDF document. And actually it will go off of that basically going forward. So now to actually use the Ollama version, what we're going to do is we're going to import Ollama. I'll just go ahead and do it manually here. So we're going to go ahead and first off grab the LlamaIndex LLMs and change this to basically Ollama. Then we use basically the same import as the package name. So that is, from, I'll just go ahead and grab this right here. And then we'll go ahead and do import Ollama. And then LLM equals to Ollama. We pass in the model that we want. In our case, it's Llama 3. But again, you have a lot of options in there. And then I'll just go ahead and add in my request timeout that we can use like this. Now, of course, those of you who know Python really well know that you can't use these dashes here. So we put an underscore for LlamaIndex. Then we do dot for LLMs and then dot for Ollama. And what do you know? There is our new LLM. And once again, we can do settings.llm equals to LLM. Great. Okay, so we want to make sure that all of these things are defined. So let's go ahead and do that now. Now that we've got a new LLM, let's take a look at how we can change our embedding model to something local as well. Now, Hugging Face has a lot of embedding models that you can use locally. Once again, these things are going to just continue to improve. At some point, the local ones might be better than the proprietary ones. The open source ones might be, because that's what it seems like everything's going towards. But again, back into our LlamaIndex component guides, we've got these embeddings here. This actually gives us the one for both OpenAI's embedding, the default one. Once again, you can change that, but then also the Hugging Face one, which is this one right here. So I'll go ahead and bring this in, and we'll paste this into our pip install. And then I'll go ahead and come down into, basically copying and pasting these two things here. So I'll go ahead and do a plus here, and there we go. So naturally, we could change these settings together and have them all work. But now that when I run this, this should actually download the embedding model for you. You could also use large like I have here. The large one is going to be, a lot larger than the small one, which might mean a lot more resources locally. So setting these things globally means that all of my future commands that I run will use those things as well. So I'm going to go ahead and stick with the large one, just make sure that I run that. And then I'll go ahead and create my new index. I'm just going to go ahead and use this as a non-persistent vector store just for the purposes of understanding here and seeing what's going on. But I can go ahead and run this. Adding this show progress is pretty nice because it'll show me how quickly these embeddings are being made. So the large one will take longer for these embeddings, but the performance, the actual query responses should be better overall based off of what we're giving it, right? Maybe it's not better in terms of, what like GPT-4 might do, the LLMs and stuff like that. That's not really the point. It will be better for what it's doing inside of that PDF document itself. Or if we had a bunch of PDF documents, which you could totally add a bunch more, right? Because of that reader, we could add a whole series of PDF documents that talk a lot more about Django. And it could be code, it could be all sorts of things. And then this embeddings would be, or actually the query would be that much more powerful. The embeddings would take a lot longer, but overall, that's it. So hopefully that helps you better understand as to what's going on with these query engine and LlamaIndex. There's a lot more things that you can do in here, and it is pretty broad in terms of how well it works too. It depends on the models that you're using and the models that are available, and of course also the key part being the data you're actually feeding in there as well. So using a powerful LLM will help us with better responses in general for things that are just not available in that PDF data. I'm going to let this finish and we'll see what happens. And here's the response that I get. And of course, if I ask it again, it's going to give me a different answer. It gives me different answers almost every single time. Now, this is because of two things. Number one, this is not semantic search. This is not searching the PDF document for this answer. Instead, it's doing that and then it's interpreting it. It's actually synthesizing the response itself. So if I did models.char field, then this should use the context of our actual, PDF document. And now this is actually giving me basically the same response every single time, roughly speaking. I can also add in maybe explain them, right? I could add that in as well to give a little bit more of an explanation as to what's going on in here, which is nice. I can also use something a little bit more like what is an example model, return as Python format, run this. This again will do a search in the vector database that will give it a bunch of context. Then it will return that context. The LLM will then synthesize what that context is and then finally give you a result of some kind. In this case, it gives us a fairly accurate model. Now, of course, we can also test this out by doing semantic search into our vector database, which I don't have set up yet. But what we could also do is we could actually bring this question into our LLM itself. So if I run ollama run llama 3 and then just do this same question, it's very generic. It doesn't mean a whole lot. And then it gives me back some data in terms of, pandas and sklearn. Has nothing to do with Django. This one, at least every single time I do that, should have something to do with Django. Maybe an example model with, I'll go ahead and say with 5 fields and run that. This will give me yet another example as to what's going on with this model itself. And there we go, right? So it's quite a bit different. An example product model with 5 fields, right? Once again, it will give me something related to Django. This same question, it still might work with my LLM. It still might give me that same stuff. And of course, if I put in Django in there, it might give me an even better model itself. This is not it, right? So again, I'll go ahead and press up and I'll say return as Python format with Django models or something like that. That might give me maybe the same exact thing and maybe even a better result. But the point of this is not so much of the results related to Django or any given code. The point of this is it's taking all of the context available in that vector database as a key part of how it's going to respond and synthesize that data. You can always change those responses, right? So if you go into the LlamaIndex, this is one more thing that's a lot more advanced for how you end up doing your querying. You can change your response synthesis altogether on how you actually respond to this data, right? So there's a lot of things in here that you can make this even more robust, which is something outside the scope of what we're trying to do. But hopefully now you have a better sense as to what's going on with LlamaIndex and how it relates to embedding models, LLMs, and also, well, OpenAI, a lot of the defaults that we had out of the gates. So hopefully this helps improve what your Slackbot can actually do and give you a better understanding of what's actually happening under the hood. Hey, thanks so much for watching. Hopefully you got a lot out of this. Now, I do think that Slackbots are here to stay. What we see here is a very narrow use case in the sense that we're talking to one single PDF. But of course, we could repeat this process over and over again with all kinds of Slackbots. We could do it as one single Slackbot that has some conditional logic, kind of like a command line tool to call all of these other different index values and different query engines that we built out. That would be actually pretty fascinating to see. So the next challenge after that would be, how do you actually get this into production? How do you deploy it? Now, luckily for us, we used a lot of third-party services to manage the ecosystem for us. Obviously, we used OpenAI's GPT models, but we also used Upstash, which of course, we just need to bring those environment variables into production, and then we've got our system running. We really just need to worry about a production database for Django and having a runtime for Celery, and then boom, everything is now in production. So we're really, really close to doing something like that. Now, I will say, once you actually do put it into production and you do have a Django-ready database, like a Postgres database, how do you actually use that database in conjunction with LlamaIndex so your chatbot can actually talk to the database then, which it definitely can. It's another feature of LlamaIndex that I think is really cool and really fascinating. So let me know in the comments if you want to see something like that. Otherwise, thanks again for watching. My name is Justin Mitchell. I look forward to seeing you in a future video. Thanks again.